Okay, so you know all those sci-fi movies with like robots,
Right.
the ones that look like they were built in someone's basement.
Yeah.
Forget about those.
Yeah.
We're going deep on humanoid robots.
The ones that are like actually starting to, step off the screen and into our world.
Exactly.
Yeah.
Like real deal stuff. And what's so fascinating to me, at least I don't know about you, is why even make a robot that looks like us?
Right.
Like, what's the point?
I think that's, a question a lot of people are asking themselves right now. Why build a machine in our image? And I think it kind of gets at this idea of, building robots that can work in our world.
Yeah.
Our world is very much designed for humans, by humans, with humans in mind.
Yeah, because it's like if you have a robot with wheels,
Right.
it's not going to be able to go up the stairs.
Exactly. You're not going to, you think about all the things that would have to change in our world.
Yeah.
If we wanted to design a robot that wasn't humanoid.
It's true.
Right. Think of doorknobs and stairs and all the tools that we use.
So it's easier to shape the robot like a human than to rebuild our entire world.
In a lot of ways, yes.
Yeah.
It's about creating robots that can integrate seamlessly.
Yeah. That actually makes a lot of sense.
Yeah.
But I gotta say, okay, some of these robots that I'm seeing,
Yeah.
they seem more about like the show, the pizzazz,
Sure.
than like actual helpfulness.
Yeah.
Like, I don't know how helpful it is to have a robot that can pour me a cup of coffee.
Right. Right.
Like, that seems a little, I don't know, extra.
Yeah. I think you're hitting upon a really important point, which is that there's this whole kind of subset of humanoid robots that are demonstration robots.
Yeah.
And they're designed really to, wow at conferences and get people excited about the technology.
Right.
But don't be fooled by the theatrics, because there are practical applications of this technology that are emerging in various fields.
Oh, yeah. No, for sure. Like, when I saw the stuff about robots in medicine,
Yeah.
like, that just blew my mind.
Yeah. Like, I had no idea that that was a thing.
Yeah. It's really remarkable what they're able to do.
Like, they can actually help with, like, rehabilitation and stuff.
Yeah. So, like, for people who've had, problems with their lower limbs,
Yeah.
they've got robots now, like, Wabian 2 is one,
Okay.
where the robots are actually able to, like, work alongside patients.
That's so cool.
And help them regain mobility and things like that.
That's wild.
Yeah, it's really kind of a glimpse into the future of what robotics can do in healthcare.
Totally. And it's not even just here, right? Like, I was reading about robots in space,
Yeah.
which just seems wild to me, like sending robots to space instead of people.
It's a very real possibility.
Right.
And it makes a lot of sense if you think about it. If you're sending a robot to space,
Right.
you don't have to worry about life support.
You don't have to bring it back.
Exactly. You don't have to worry about, them going crazy because they've been up there for years.
Right.
All those sorts of things. It's true. Yeah, no, I mean, it makes sense. But how do they even, like, if we're sending robots to space or robots are working in a hospital,
Yeah.
how do they, like, see the world and know what to do?
Well, that's where things get even more interesting, because they have these things called tactile sensors,
Tactile sensors.
which are often called tactiles. And essentially, they mimic the human sense of touch.
Okay.
So if you think about, like, when you touch something, you get information from your fingertips.
Totally. Like, if it's hot or
So-
cold,
Or rough or
well,
something.
you're getting pressure, you're getting temperature, you're getting texture. Robots need that same information,
Okay.
and they gather it through these tactile sensors.
So they're like robot fingertips.
Essentially, yes.
Okay.
And the density of these sensors can really vary. Like, there's a robot called the Shadow Hand, which has 34 tactiles per fingertip.
34. That's intense. That's way more than I have on my own hands.
Right. It's pretty amazing. That's wild. Okay, so they're sensing, but then how are they actually moving?
So movement comes from actuators, which are essentially the muscles of a humanoid robot.
Okay.
These are the motors and systems that translate commands into physical motion. And you've got different types of actuators, each with their own strengths and weaknesses. The most common type are electric actuators,
Okay.
and they're really popular for their precision
Okay.
and speed.
So like little tiny electric motors, basically.
Kind of, yeah.
Okay.
You can think of it that way, like a miniature version of what you might find in an electric car, just much smaller, more specialized. They often lack the raw power, though, that you need for a really big, powerful humanoid robot.
Okay.
So to overcome that, Sometimes you'll see robots that use groups of electric actuators working together. So, for example, there's a robot called the HRP2,
Okay.
and it uses multiple electric actuators in a coordinated way to generate the force needed for its movements.
Oh, interesting. So it's like teamwork, but for robots.
Exactly. It's all about finding clever engineering solutions to overcome the limitations of each type of actuator.
That makes sense. So what about those robots that you see like from Boston Dynamics?
You're right.
The ones that are like insanely strong and agile.
Like ATLAs, for example.
Yeah, exactly. Like that thing can do backflips.
Right.
There's no way those are just tiny electric motors powering that, right?
Yeah, you're right. ATLAs actually uses hydraulic actuators.
Hydraulic.
Yes. So instead of electricity, hydraulic systems use fluid pressure to generate force.
Okay.
Think of it like, those big machines you see at construction sites.
Okay, yeah.
They use hydraulics to lift and move heavy objects. And that's what gives ATLAs its incredible strength and agility. But it comes in the trade-off.
What's that?
Hydraulic systems, while super powerful, are much bulkier and complex than electric actuators.
Oh, I see. So it's a trade-off between like raw power versus like being sleek and compact.
Exactly. It depends on the specific task or purpose of the robot. If you need something incredibly strong and you don't mind it being a little bulky, hydraulics are the way to go. But if you need something more agile and compact, then electric actuators might be a better choice. Or there's always the third option, electrohydrostatic actuators, or EHAs for short.
EHAs, what are those? Are those kind of like a hybrid of the two?
Yeah, that's a great way to think about it. EHAs combine the power of hydraulics with the efficiency and compactness of electric actuators.
Oh, wow. So best of both worlds.
Potentially, yes. It's a very exciting area of development in robotics. They offer a lot of promise for the future.
Definitely something to keep an eye on. Okay, so we've talked about the muscles, but what about the brains behind these humanoid robots? How do they make decisions?
That's where we get into the world of planning and control systems. It's a complex field, but essentially these systems act as the robot's brain.
Okay.
They use a combination of software, algorithms, and sensor data to perceive the environment, make decisions, and then execute actions.
So are we talking about robots that can actually think for themselves?
That's the ultimate goal, but it's much more nuanced than that. Right now, we're still in the early stages of developing robots that can truly think independently.
Right.
It involves things like artificial intelligence, machine learning, and a deep understanding of how human cognition works.
So no robot overlords just yet.
Not quite. But there's been incredible progress in recent years. For humanoid robots to be truly useful in our unpredictable world, they need to be adaptable.
Yeah.
They need to be able to handle new situations, make decisions on the fly, and learn from their experiences.
So it's not just about programming them to do one specific task.
Exactly. It's about giving them the tools and the intelligence to navigate complex, ever-changing environments, to be able to adapt to unexpected situations.
So instead of following a strict set of rules, they're learning to improvise.
In a way, yes. And that requires a level of artificial intelligence that goes far beyond what we've achieved so far.
It's exciting and a little bit intimidating all at the same time. Okay, so where did this whole idea of humanoid robots even come from?
You might be surprised to learn that it's not just a product of modern science fiction.
Oh, really?
The desire to create artificial beings has actually been around for centuries.
No way.
You can find traces of it in ancient myths and stories from cultures all over the world.
Like what? Give me an example.
Well, the ancient Greeks had myths about Talos, a giant bronze automaton that protected the island of Crete.
Oh, okay.
And in China, there were legends of mechanical men and women dating back to the Han Dynasty.
Wow. I had no idea it went back that far.
The idea of creating artificial humans seems to be something that has captivated the human imagination for millennia. Of course, the technology to actually build such machines didn't exist back then.
Right.
But the seeds of the idea were sown a long, long time ago.
Fascinating. So when did we start moving beyond just myths and legends and actually trying to make these things?
Well, you can find evidence of early attempts throughout history. During the Middle Ages and the Renaissance, there were skilled artisans creating intricate automatons.
Automatons, like what?
Think of those elaborate clockwork figures that could move and perform actions. They were often designed to entertain royalty and demonstrate the ingenuity of the inventors.
Oh, right, like those little mechanical birds that could sing and flap their wings.
Exactly. They were marvels of engineering for their time, even if they weren't exactly intelligent by today's standards. But those early efforts laid the groundwork for the development of robotics as we know it today. And when we talk about modern robotics, one country that often comes to mind is Japan.
Yeah, for sure. Japan seems to have a real fascination with robots.
They do. It's deeply ingrained in their culture.
Why do you think that is?
It's a complex mix of factors, I think. Part of it is their cultural openness to new technologies and their willingness to embrace innovation. They don't seem to have the same fear of robots that you sometimes see in Western cultures.
That's interesting. Yeah, you're right. There's definitely like a fear factor sometimes.
There's also a deep respect for craftsmanship and automation in Japanese culture. They see beauty in precision and efficiency, which aligns well with the field of robotics.
That makes sense. And I'm also thinking of their Shinto beliefs, where objects can have spirits. That must play a role too, right?
Absolutely. Shinto animism blurs the lines between the animate and inanimate in a way that makes robots seem less foreign, less threatening.
So it's not just about the technology itself, but also about how that technology fits into their worldview.
Exactly. It's about cultural context and how that shapes our perception and acceptance of new ideas. And this is reflected in their robotics industry as well.
Oh, totally. Like I'm thinking of Honda's Osmo robot. That was a huge deal when it came out.
Osmo was groundbreaking. It was one of the first humanoid robots that could walk and run on two legs in a way that looked surprisingly human-like. It was a major milestone in robotics.
Yeah, it really captured the imagination. It felt like the future had arrived.
And it paved the way for many of the advancements we're seeing today. Another significant development was the iCub robot, which emerged in the early 2000s.
The iCub robot. What was special about that one?
Well, unlike many robots before it, the iCub was specifically designed to learn and interact with its environment, much like a human child would.
Oh, wow. That's fascinating. So it's not just about building a robot that can perform tasks, it's about building a robot that can learn and adapt.
Exactly. The iCub project was all about understanding how robots can acquire knowledge and skills through experience, just like humans do. It was a major step forward in the field of developmental robotics.
Wow. So it seems like every breakthrough in robotics brings us closer to that science fiction vision of the future where robots are a part of our everyday lives.
It does feel that way, doesn't it? It's an exciting time to be following this field. There's so much happening, so much potential.
It really does feel like we're on the cusp of something big. But before we get too caught up in the future, I want to bring it back down to earth for a moment. What's the state of humanoid robots right now in the real world?
That's a great question. And the answer is, it's a time of both incredible progress and ongoing challenges. We're witnessing a surge of innovation and investment in robotics, largely driven by those incredible advances we've been talking about.
Right.
Artificial intelligence, sensor technology, manufacturing techniques, they've all come a long way. And this is translating into some really exciting developments in the field.
So it's a good time to be paying attention to this field.
Absolutely.
Yeah.
If you're interested in the future of technology, robotics is definitely a field to watch. Companies and research labs around the world are racing to develop the next generation of robots, and the applications are expanding rapidly.
So it's not just about research and development anymore. These robots are actually starting to make their way out into the real world.
Exactly. We're seeing them being used in a growing number of fields. Of course, there are those demonstration robots that we talked about earlier.
Right, the ones showing off at conferences?
Exactly.
Yeah.
But we're also seeing them being used in more practical ways, like in healthcare, as you mentioned earlier, assisting with surgery, rehabilitation, and even providing companionship for elderly patients.
Wow, that's incredible.
And we're also seeing them being used in manufacturing, logistics, search and rescue, and even space exploration. The possibilities seem almost endless.
It really does feel like we're on the verge of a new era where robots are poised to become a much bigger part of our lives. It's both exciting and, to be honest, a little bit daunting.
I understand that. It's a natural reaction to such a transformative technology. And it highlights something really important that we need to be talking about. As exciting as these advancements are, we also need to be thinking about the ethical and societal implications of humanoid robots.
That's a really good point. It's not just about the technology itself, but also about how we use it and what impact it has on our lives.
Exactly. We need to make sure that we're developing and using this technology responsibly and ethically.
Right. So it's not just about building smarter robots, but about building a better future with robots.
Precisely. We need to consider the potential consequences of our actions and make sure that we're steering this technology in a direction that benefits all of humanity.
That's a great point. And it's something that we should all be thinking about. Speaking of steering technology, earlier we briefly touched upon Tesla and their somewhat surprising entry into the world of humanoid robots.
Yes. Their Optimus bot has definitely been generating a lot of buzz. It's a fascinating development.
It is, and it seems like they're approaching it with their signature blend of ambition and pragmatism.
Absolutely. And I think that's what makes Tesla such a disruptive force in any industry they enter. They're not afraid to challenge the status quo, and they have a knack for making the seemingly impossible possible.
It's true. They have a way of capturing the public's imagination.
They do, and that's no small feat, especially in a field as complex and rapidly evolving as robotics.
No, not at all. So let's talk about Tesla's approach to humanoid robots. What are they doing differently? What are their goals, and what are the challenges they're facing?
Well, one of the most striking things about Tesla's approach is their focus on practicality. They're not just trying to build the most advanced robot in a lab setting.
Right.
Their goal with Optimus is to create a robot that's actually useful and affordable for everyday tasks.
So it's like their philosophy with electric cars. Take something that's seen as futuristic and niche and turn it into something mainstream.
Exactly. They want to make robots accessible to the masses, not just to research institutions and wealthy corporations.
It's an ambitious goal, to be sure, but can they actually pull it off? I mean, there's a lot of skepticism out there, right?
There is, and understandably so. Building robots for a controlled factory environment is one thing.
Yeah.
But creating a humanoid robot that can navigate the complexities of our homes and workplaces,
Right.
that's a whole other challenge.
It's like the difference between a Roomba cleaning a living room versus a robot that can tidy up a teenager's bedroom. One is predictable, the other, not so much.
That's a perfect analogy. But here's the thing. While Tesla has faced some challenges in automating parts of their car production,
Right.
those experiences have actually been invaluable learning opportunities. They've encountered the difficulties of robotics firsthand.
Right.
And that practical experience could give them an edge in developing Optimus.
So they're learning from their mistakes, adapting and applying those lessons to their robotics program.
Exactly. They're not afraid to experiment, even if it means encountering setbacks along the way. That willingness to iterate and learn from their mistakes is a big part of what makes Tesla so innovative.
It'll definitely be interesting to see how it all plays out. Okay, so they're learning, they're adapting, but can they actually crack the code on affordable, multi-purpose humanoid robots? Time will tell, I guess.
Time will tell. But one thing's for sure, their entry into the field has the potential to shake things up and accelerate progress across the industry.
It's going to be exciting to watch, that's for sure.
Absolutely. And as we watch this unfold, it's important to remember that it's not just about the technology itself. It's about the impact it will have on our lives, on our society.
That's right. And that brings us back to those ethical questions that we touched upon earlier. It's something we need to be thinking about now as these technologies continue to develop.
Absolutely. We need to be having open and honest conversations about the potential benefits and risks of humanoid robots. And we need to make sure that we're developing and using this technology in a way that benefits everyone.
It's a responsibility that falls on all of us, not just scientists and engineers.
I agree. We need ethicists, policymakers, philosophers. Everyone needs to be involved in shaping this future that we're creating.
So as we wrap up our deep dive into humanoid robots, I think the key takeaway is that this is a field with incredible potential, but also with significant challenges and ethical considerations.
Well said. It's not something to be feared or blindly celebrated. It's something to be approached thoughtfully and with careful consideration.
We need to remember that technology is a tool, and how we use that tool ultimately depends on us.
That's a great point to end on. Ultimately, the future of humanoid robots is up to us to shape. And it's a future that has the potential to be incredibly exciting if we approach it with wisdom, responsibility, and a commitment to the greater good.
I completely agree.
It's a fascinating question that, where did this whole idea even come from?
Yeah, are we talking old sci-fi books? Is that where this all started?
You know, it's funny you should say that because it actually goes back way further than you might think.
Really?
Oh, yeah. We're talking centuries, millennia even. The ancient Greeks, they had myths about artificial beings.
No way. I always think of the myths with the gods and the monsters and all that.
Right.
Not robots.
But they also had stories about Telos, this giant bronze automaton, supposedly guarded the island of Crete.
Oh, wow.
And even in ancient China, way back in the Han Dynasty, you had these legends of mechanical men and women. So this whole fascination with creating artificial beings, it's not new at all.
That's so interesting. Huh. So it's like one of those things that's just kind of like been with us throughout history?
Totally. Like
Wow.
this deep-seated human desire to create in our own image. And of course, back then they didn't have the technology to actually build these things.
Right.
But it's amazing to see how those early myths and stories have kind of echoed through time.
Totally. It's like they were ahead of their time in a way. But when did we start actually trying to build these things, like move beyond the myths?
Well, you see these little glimpses throughout history, like in the Middle Ages and the Renaissance, you had these really skilled artisans, right?
Yeah.
Creating these incredibly intricate automatons.
Automatons. Now, remind me what that is again.
So think like clockwork figures, right?
Yeah.
They could move, maybe perform some actions. They were all mechanical, of course.
Oh, right. Like those little mechanical birds that could sing.
Exactly.
Right. Yeah. Very fancy toys.
Yeah, they were often designed to entertain royalty, demonstrate the ingenuity of the inventor.
Yeah.
But they were really marvels of engineering for their time.
Yeah.
And even though they weren't, intelligent by today's standards,
Right.
they represent these really important early steps towards modern robotics.
Totally. And speaking of modern robotics,
Yeah.
can we talk about Japan for a second? Because they are like all about the robots.
Right. Japan has this long, fascinating history with robots. It's really kind of woven into their culture.
It's true. It's like they don't even question it.
Yeah, it's so interesting how it's so normalized there.
Yeah.
And I think part of it has to do with their cultural openness to new technologies in general. Like they embrace innovation.
Yeah.
They don't seem to have the same kind of fear or hesitation around robots.
It's true. It's like some people I think are kind of afraid of robots,
Right.
Like, what does it mean for humanity?
Exactly.
Yeah.
Like existential dread.
Yeah.
But Japan, it's like they skip right over that part and they're like, this is cool, let's make more.
Totally.
And, they have this deep respect for craftsmanship,
That's true.
for automation.
Yeah.
They see beauty in precision and efficiency. And that really aligns with the whole field of robotics.
Totally. I never even thought about it that way. And their religious beliefs too, right?
Right. Shintoism.
Yeah, where like objects can have spirits.
Exactly. That plays a huge role too, because it kind of blurs the lines between living beings and inanimate objects.
It's true. So it makes robots seem less like a threat.
Right. Like it's not such a foreign concept.
Yeah. Yeah.
And all of that is reflected in the robotics industry, which is incredibly advanced and innovative.
Totally. They're leading the way in a lot of ways.
Yeah.
It's pretty amazing. And I
Okay.
feel like one of the most iconic examples of that is Honda's Asimo robot. Remember that?
Oh, of course. Asimo was a game changer
It really was. Like, it could walk and run.
on two legs, like a person.
It was amazing. It felt so futuristic at the time.
It did. And it really helped to push the boundaries of what was possible in robotics.
Totally. And I feel like Asimo, it really paved the way for a lot of the advancements that we're seeing today.
Absolutely. It's considered a landmark achievement in the field.
Oh.
And another one that's really fascinating is the iCub robot.
Okay, the iCub. What was so special about that one?
So unlike a lot of robots before it, which were programmed to do very specific tasks, the iCub was actually designed to learn and interact with its environment, much like a human child would.
Oh, wow. That's so interesting. So it's not just about telling it what to do, it's about it figuring things out for itself.
Exactly.
Yeah.
The iCub project was all about understanding how robots can acquire knowledge and skills through experience, just like we do.
Wow.
And that was a huge step forward in developmental robotics.
That's really cool. So it seems like with every breakthrough, every new robot that comes out, we're getting closer and closer to that sci-fi vision of the future, right?
It does feel that way, doesn't it?
Yeah.
Where robots are just going to be seamlessly integrated into our lives.
Yeah. It's exciting, but it's also a little, I don't know.
A little intimidating.
Yeah. Like, how will it all actually play out in the real world?
Right. That's the million-dollar question, isn't it? Because we're still in the early stages of all of this.
Yeah,
And there's a lot of potential, but also a lot of challenges still to overcome.
totally. So let's bring it back down to earth for a moment.
Okay.
What is the state of humanoid robots, like right now, in the real world?
It's a great question. And honestly, it's a really exciting time to be following this field because on one hand, you have this incredible progress being made.
Yeah.
Like we're seeing huge advancements in artificial intelligence,
Right.
sensor technology, manufacturing techniques, and all of that is fueling this surge in innovation and investment in robotics.
Yeah, it feels like there's so much happening right now.
There really is. Companies, research labs all over the world, they're racing to develop this next generation of robots.
It's like a new space race but with robots.
Right, exactly.
Yeah.
And the potential applications for these robots, they're expanding so rapidly. It's not just, those demonstration robots we see at conferences anymore.
Right.
We're seeing them being used in healthcare, in manufacturing, logistics, even things like search and rescue and space exploration.
It's true. It's amazing to see how far things have come.
It really is. And it really does feel like we're on the verge of a new era.
It does. It's exciting. But to be honest, I'm not going to lie, it's a little bit daunting too.
It makes sense to feel that way. It's a natural reaction to such transformative technology, right?
Yeah.
Like it makes you question things,
Totally. Like, what does this all mean for the future? What does it mean for us?
Exactly. And it highlights something really important, which is that as we develop these amazing new technologies, we also need to be thinking about the ethical implications.
Yeah, for sure. It's not just about the technology itself. It's about how we use it.
Right. We have a responsibility to make sure we're developing and using this technology responsibly.
Absolutely. So how do we do that?
Well, for starters, I think it's crucial to have these open and honest conversations about the potential benefits and risks of humanoid robots.
Right, which is kind of what we're doing right now.
Exactly. We need to be talking about these things, not shying away from the difficult questions.
Totally. So it's not just a job for scientists and engineers to figure out.
Right. It's on all of us.
Yeah.
We need to be thinking critically, asking tough questions, and making sure our voices are heard.
Yeah, because ultimately it's going to impact all of us.
Exactly. And we have a responsibility to shape this technology in a way that benefits everyone.
I love that. So it's not just about building smarter robots, it's about building a better future, right?
Exactly. A future where this technology empowers us, where it helps us to create a more equitable and sustainable world.
I love that vision. So speaking of building a better future, earlier we were talking about Tesla and their, I guess you could say, surprising entry into the world of humanoid robots.
Right. With their Optimus bot. It's definitely shaken things up a bit.
It has, because on the one hand, it seems kind of out of left field for a car company to be like, we're making robots now.
Right. It's like, wait, what?
But then again, knowing Tesla, it also kind of makes sense.
It does. It's very on brand for them to be like, we're going to do this big, ambitious thing that everyone thinks is crazy.
Totally.
And maybe they'll pull it off, maybe they won't, but they're going for it.
Right. They seem to have this knack for doing that.
They do. Oh, and I think that's why people are so fascinated by them, even if they're not, Tesla fans themselves. It's like, you can't help but watch and be like, what are they going to do next?
Totally, totally. So let's dive into their approach to humanoid robots. What are they doing that's different from everyone else?
Well, I think one of the most interesting things about Tesla's approach is that they really seem to be focusing on practicality.
Okay.
Like they're not just trying to build the most advanced, cutting edge robot in a lab somewhere.
Right.
Their goal with Optimus seems to be to create a robot that's actually useful for everyday tasks.
Okay, so like a robot that could actually fold my laundry.
Exactly.
And not just walk around on the stage and wave.
Right, exactly. They want to make robots accessible to everyone.
Okay.
Not just big corporations or research labs.
So almost like taking something that's seen as futuristic and kind of niche.
Right. And turning it into something that's mainstream.
Exactly. Like they did with electric cars.
Yeah, totally. It's ambitious, for sure.
Hugely ambitious.
But can they actually pull it off?
That's the million-dollar question.
All right.
And, I think there's definitely some healthy skepticism out there.
Yeah, for sure. Because it seems like a big leap.
It is a big leap. And building robots for a factory setting, like we talked about,
right?
That's one thing.
Yeah.
But building one that can navigate, my house.
Right, exactly. Like, a factory is predictable.
Right.
The real world, not so much.
Exactly. But here's the thing. They've encountered a lot of those challenges firsthand. Because they've been trying to automate parts of their car production.
Right. They've hit some bumps in the road with that, haven't they?
They have. But those experiences, as frustrating as they might be in the moment, those are invaluable learning opportunities.
Yeah. They're seeing firsthand what works, what doesn't work. What are the challenges of integrating robots into these complex environments?
So it's like they're learning from their mistakes.
Exactly.
Yeah.
And that's something that Tesla's really good at, right? They experiment, they iterate. They're not afraid to fail.
Right. They're constantly adapting.
Exactly.
Okay, so that's definitely interesting. They're learning, they're adapting, but it's like, is it actually going to work? Can they actually crack the code on this whole affordable, multi-purpose humanoid robot thing?
Right. And I think only time will tell.
Yeah.
But I think one thing's for sure.
What's that?
Their entry into this field has the potential to be really disruptive.
In a good way or a bad way?
I think that remains to be seen,
Yeah.
but I think it's going to accelerate progress across the whole industry.
Okay. Yeah. Competition often breeds innovation.
Exactly.
So it'll be interesting to see how it all unfolds.
For sure.
But I do want to, before we totally wrap up here,
Right.
I want to go back to these ethical questions for a second.
Of course.
Because it's really easy to get caught up in all the cool technology and the what ifs and the possibilities.
Right.
But we also need to be mindful of the impact this is all going to have on our lives.
Absolutely. And that's something that we, I think, need to be thinking about now, not down the road when it's too late.
Totally.
Like, as these robots become more capable, how do we make sure they're used for good?
Right.
How do we prepare for the impact on the workforce? These are big questions.
Huge question.
And there's not easy answers.
No, but we have to at least start asking them.
Exactly. And I think that's on all of us, right?
Right. Not just the scientists.
Not just the engineers, not just the policymakers.
Yeah.
Like, we all need to be part of this conversation.
Totally. Because it's going to impact all of us.
Exactly.
So I guess as we wrap up here,
Yeah,
we've covered a lot of ground.
we have. From ancient myths to Tesla bots.
It's mind-blowing.
It really is. And it's a lot to process.
It is. So I think if there's one thing that I hope our listeners take away from all of this,
Yeah.
it's that the future of humanoid robots, it's not something to be afraid of. It's not something to just blindly celebrate either.
Right.
It's something that we have the power to shape.
Exactly. We have a voice.
Yeah.
We have a choice in how this technology is developed and used. And I think that's really empowering.
It is. It's exciting. It means we're not just along for the ride. We're actually helping to steer.
Exactly. And that's what makes this such an important conversation to be having.
Totally. So to all our listeners out there,
Yeah.
keep asking those tough questions. Keep the conversation going.
Exactly. Because the future of humanoid robots, it's not predetermined.
Right.
We get to help write that story.
I love that. On that note, I think we're going to wrap it up.
Sounds good.
But, this conversation, it's just getting started.
Absolutely. It's just the beginning.
All right. Thanks for joining us on this deep dive.
Yes. Thanks, everyone.
And until next time.